in regression, we are predicting the value of dependent variable based on the given independent variables.
Okay.
We are trying to predict the
Okay.
numerical,
We're not, yeah.
okay, numerical independent variable based on, okay, what are
Okay.
different techniques that we have used? We have done linear regression, we have
Yes.
done SVM, support vector machine, we have done decision tree, we have done random forest.
Random forest. Yes, sir.
Right? Anything else we have done?
I think so. Polynomial regression and all this comes under regression only.
Yes. So only in linear regression we do draw a line, best fit line.
Yes, yes, sir.
Okay. So what are the steps that we follow? What are the steps? High level steps.
First thing is pre-processing of the data.
Tell me the steps. Don't tell me pre-processing, processing, post-processing. What is pre-processing? Tell me everything. Don't tell me pre-processing.
Yes, sir.
Pre-processing, processing, post-processing. Done. That is, every process is like that only, right?
Sorry.
You cut
Yes,
the,
sir.
cooking also pre-processing, processing, and post-processing, right?
Okay.
So how is cooking different than data analysis?
Okay. First, we will separate the data set into X and Y, sir. X is independent variable set and Y is the dependent variable, what we need to predict. And then after separating, we'll try to
What
fill the
is
missing values.
trying? What is trying?
Okay, we will. And then missing values and all should be filled up.
First, we make data ready for analysis. So
Yes,
data
sir.
can have missing value, can have outliers. Okay, it will have text data, it will have categorical
Numerical
data. So
Yes,
so
sir.
we perform. Okay, fine, done. Next step.
After that, we'll split the data set into training and test set.
Okay, why do we do training and test set split?
First thing, we'll train the algorithm using the train set. And after the algorithm is trained with the given set, we'll test it on the same data sample. Based on the outcome, then we'll pass the X test after the algorithm is trained, and then we'll get the predicted values for the output Y.
Correct.
Then we'll compare with these predicted values with the test values Y, and then we'll perform various statistical parameters, sir. We'll calculate statistical parameters like variance, R square, RMSC, NAE, and all based on the values. And we can also plot some graphs so to check the relation between the variables. Based on that, we can decide whether which algorithm will best suit, which model can be best applied on the given data set.
Right. Okay.
Yes, sir.
So based on that, okay, you have, let's say I put test result here and you have training result here.
Okay.
Okay. So training result is like, let's say, you have learned in the class, you have answered in the class. Okay.
Yeah.
You answered all the, so your accuracy is high, your error is less, RMSE is low, R square is high. Okay. You can have low here and low here. So typically what happens is, okay,
yeah,
when you have, if you have not performed well on training, okay, you will not perform well in test also.
Obviously. Yeah.
Right. So this is what you will generally see. Okay. But so that's why, see, you have to always, whenever you are doing analysis, right, you have to find R square and RMSE for both test and train.
Yes, sir.
For both test and train, you have to find R square and RMSE, and you need to compare them. Okay. So If they both are low accuracy, that means, it's giving 60 or 60 or 50, 50, 70, 70. Okay. So this is one possibilities, and this is other possibilities where both of them give high. This is your normal observation. Okay. When you see this, that means everything is fine. You don't have to do, okay, anything much about it. But when things are not like that, when things fall here or here it means that your training is low, but test is high, which is kind of doubt. Okay, you don't generally see this. Okay, generally we don't see this, that you are performing low on training but very high in the test. Okay, if you don't do well in the class, if you can't answer in the class, definitely you can't answer in the interview, right? So this situation kind of doesn't exist. If you see something like that, when training is low, the training accuracy is high. Sorry, training accuracy, I'm talking about accuracy, not error. If training accuracy is low, okay, but test accuracy is high, probably you have not you have not taken the data set properly. Okay. Okay, but what is of interest is when your training is high and test is low. This is very much possible. So when we speak about training your model, right, we said that in polynomial increase the degree, in SVM you increase your C and gamma values, right? In decision tree or random forest we increase that number of trees, right? We have different parameters, right? Now this is what happens. Okay, it's like this: if you are doing well in training and if you're not able to do well in the test, that means you are kind of um, doing by hearting stuff, isn't it? Okay, when you by heart things, okay, you'll be able to answer well. Okay, but when they ask interview, okay, if the question is changed, you will not be able to answer, isn't it? This situation we have to deal with. Okay, this is where, okay, you have to decide. You should not just go by increasing the training accuracy. If your training accuracy is keep on increasing, doing better, let's say 99%, 99.9%, but test is getting 70%, 60%, that means you have done overfitting. This is called overfitting. Okay,
Yes.
overfitting is situation where you are you are too much focused on training but ignoring the test. Okay, so generally what happens is you will start from this situation, low, right? If it is high, then that's where you stop, right? You don't have to proceed any further. Okay, so your accuracy is low, that's why you want to change the parameters, right? You want to get higher accuracy. So you want to reach from this stage to this stage. Your objective of changing the parameters or changing the algorithm is to reach from this stage to this stage. Okay, reach from this stage to this stage. This is our objective. Okay, but what happens is we tend to go in this. No, you reach this stage and then you go here. Okay, this is where your training is getting better and better, but your test accuracy is going bad. So if I have to put it in a graph, I'll put another paint. Okay, so this is situation where, okay, let me draw X and Y axis. Okay, let's say this is your values, okay, or parameters or changes that you're doing, and this is your accuracy. So accuracy will be first low, right? We'll talk about training accuracy first. So training accuracy, okay, will be low, and slowly, it start increasing. Accuracy is increasing. Okay, as you change parameters, accuracy will increase. Now, when you perform the same set on the test accuracy, okay, it will also be low. Okay, it will increase up to some point and then it will start going down.
Okay.
This is where you're doing overfit. This is called overfitting situation.
Okay.
Overfitting. Overfitting is when you are focusing more on improving the accuracy, and you are, because training accuracy, because parameters you can change only in the training, right? On the test you
Yes, sir.
can't change any parameter. Test is just your regressor dot predict. There's no parameter there. In training only you're changing you're changing parameters so much that you're getting better and better training accuracy, but when you run it on test, your accuracy is going down. That's why you have to run analysis on multiple values on both training and test, and you have to draw this kind of plot. If you're not going to draw on the Excel itself, if you look at the values, you will know. Okay, for some time values is increasing. This is what we want, right? So you are changing the parameter and your accuracy is increasing. Perfect. But after this point, it goes down. That means this is your best value. Okay, you should not go any further, even though your training is getting improved, but you should not tweak the parameter, you should not change the parameter. This is where you should stop. Okay, this area is called underfitting. Overfitting is when your training accuracy is very high, but your test accuracy is going down. Underfitting is where both of them are low. Okay, what is low? Your training accuracy as well as test accuracy. So if
Okay.
this is underfitting case, you have to improve it. Let's say 60% accuracy you have got, both training and test. Okay, 61, 63, 64, 68, something, within that range. That means definitely you have to improve. That means you have to either look for different algorithm or change the parameter in the same algorithm. Okay, when you keep on doing it, right, let's say it goes up to 75. Okay, so 75, 76, 77, it's in that range. Suddenly when you increase, when you change the more parameter, training became 80%, but test became 60%. Okay, so gap has started increasing. That means you are getting into overfitting zone. So you have to come back and you have to stop here. Okay, so you have underfitting and overfitting situation. Underfitting situation is where your accuracy is low, both training and test accuracy is low. Your objective is to reach to the best fit. We call it best fit or best case. Best case is where both are high, training and test. But if you go beyond certain limit, you'll enter into overfitting zone, which is your training accuracy is high, but your test accuracy is low. Okay, we also call it bias versus variance. Bias and variance. Bias is nothing but this error. Okay, so you remember that in underfitting we have bias, and variance is in overfitting. Variance is when, okay, the gap between training and test is high. Bias is when the accuracy itself is low. So you'll hear bias. Bias is the error uh, uh, where both training and test error is low. Okay, the
Yes.
underfitting situation. Variance is that gap between your training and test. Okay, the gap between training and test is high. You end up in overfitting zone. This is the perfect zone where you need to stop. Okay, so inability of machine learning models to capture the true relationship, okay, is called bias, while training is called bias. Now when we move to test set, same model which capture data set perfectly in training fails in testing. Okay, this is the variance. Okay, which captures perfectly in training but fails in testing. Okay, this is the second half. Okay, so we say that there is a variance is high. So bias refers to error due to model simplistic assumptions. Okay, bias is normal. Okay, because when you do not do well enough, right, you do not take the right model, you do not take the correct parameters. Okay, so it is a simplistic assumptions. A high bias means the model is unable to capture the patterns, unable to capture the pattern at all, underfitting situation. Variance refers to error due to complex model. You made it so complex. Okay, that means the training accuracy has gone high, but test has gone low. This is called variance, high variance. And high variance means you are in overfitting zone. So something in between is called your, okay, so here I've taken error. Okay, what I've shown you is accuracy, and the graph talks about error. So error is high, it is going down, down, down. Validation error is also called as test. Okay, test is your validation. Okay, training is training. So okay, error is low, it is going down, which is good. And after a certain point, the gap starts increasing. Generally, your test error will be higher than the training error. Okay. So this is your best fit line. Okay, this is what you have to keep in mind. Okay, so coefficient of regression, we have already seen it is comparing how well your regression line has performed with respect to average line. This is a formula. R square equal to 1 minus, okay, your error on regression line divided by error on average line. Okay, this average on error line. And when we have generally more than one x, okay, we prefer this adjusted R square, and this is the formula of adjusted R square. Okay, P is the number of regressors. Okay, okay, so that is it. This is all we have, okay, for regression. Okay, so we discussed about linear regression, ridge lasso elastic net. When do we use ridge lasso elastic net? Ridge lasso elastic net is used when you do not have enough training data. You do not have enough data to find the pattern. Okay, when you do not have enough data, you will end up into underfitting situation.
Okay.
Okay, you'll
Yes,
end up into underfitting when you do not have enough data, because when you don't have enough data, okay, that means, okay,
training
your error
accuracy
will
will
be
be
both accuracy will be low,
less. Yes, sir. Yes.
right?
Yeah.
So such case we prefer ridge lasso elastic net when you do not have enough data. Okay.
Okay.
Now, what is enough data? There is no definition of enough data that it should be less than 1,000 rows or 10,000 rows. Okay, but you have to understand,
Depends.
right? Yeah,
Yeah.
you have to more and
Yes.
more you work,
Okay.
you will. Yeah. Okay.
Yes,
So
sir.
that's the use of ridge lasso elastic net.